All right, so we're going to continue today with factoring polynomials using our Xbox method. Okay, our Xbox method. And make sure that you are checking using either distribution or the area model to make sure that we're doing it correctly, okay? And let's go ahead and open up that factor generator to make sure that we're good to go on using it to pull factors if we need it. So remember, that is in your resources, so make sure to go ahead and open that up. And let's go ahead and take a look at our first problem today. So 3x squared minus 2x minus 8 equals 12. So I remember from yesterday that factored form was ax squared plus bx plus c equals 0. So the first thing that I see is that this is not in standard form. So it needs to be in standard form. So I need to move my 12. And moving my 12 means I have to subtract. So that would give me 3x squared minus 2x minus 20 is equal to 0. Now I have my a, my b, and my c. Okay? And to fill in my crisscross, remember that was a times c. So 3 times negative 20 is going to give me a negative 60. And my negative 2 is going to go down here at the bottom. So let's start with coming up with our factors of 60. So let's get our factor generator up here. And throw in negative 60 and see what we get. Okay, so we need a difference of 2. A difference of 2. So do you see a difference of 2? Well, let's see. I have 1 and 62 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 10 and 6. I don't see anything that's got a difference of 2. And you're right. There's nothing there. So at this point, this one cannot be factored. Okay? And when something cannot be factored, it's called prime. It's called prime when something cannot be factored. We're going to find out in the next chapter that you can actually factor everything, because sometimes they end up being decimals or radicals. But right now, factoring into whole numbers, we have no way to factor that. Okay? So it's going to be prime at this point. And we have no idea any of the rest of the numbers. We can't go any further. So this one is done at this point. Let's take a look at this next one. 4x squared minus 49y squared. So the first thing that I see is this kind of isn't in standard form either, because I'm supposed to have ax squared plus bx plus c. Well, this is my a and this is my c, but I don't have a b. That means this is really 0. So 4x squared plus 0xy would be what that middle term is, minus 49y squared. 49y squared. So this is what we're looking for. If we multiply our a and our c, we have 49 times 4. So let's get that. 49 times 4 is going to give me, whoops, that still isn't right. 49 times 4 gives me 196. So negative 196 is on top, and a 0 is on the bottom. Okay, a 0 is on the bottom. So how am I going to factor this? Well, let's take a look at our factor generator and see if it tells us anything. Let's go ahead and put in negative 196. Hey, I need a 0. How am I going to get a 0? Well, the only way that I get a 0 is if the numbers are the same. Do I have the same numbers here? Do you see that I have a positive 14 and a negative 14? That would give me 0. So a positive 14 and a negative 14. Whoops, not a 0. Negative 14. That's going to give me 0, which is what I need. Okay? So putting into my box 4x squared minus 49y squared, and these are going to have x's and y's. Okay? X's and y's. Now, Positive 14, negative 14. All right, so what can I take out of 14 and 49? Well, I can take out a 7 and a y. I know that 7 goes into 14. I know that 7 goes into 49. Okay, what can I take out of 4 and 14? Well, I can take out a 2 and an x going this way. This way, it's 4 and 14 again. It has to be a 2 and an x. And then here, negative and negative, I know I have to take out a negative. And again, it's going to be a 7. So here's what I noticed. I have 2x plus 7y, 2x minus 7y. Notice how these are exactly the same. This is actually a special factor, special product, because this is a difference of squares. 4 is a perfect square. So is x squared. So is 49, and so is y squared. We're going to spend a little bit more time working on difference of squares tomorrow. But I wanted you to kind of see what happens when you don't have the middle term. Well, it's going to be a 0. It's going to be a 0. And the way that you get a 0 is two things that are the same. Okay, so let's see if we can get this one. X squared minus 49. So again, it's going to be x squared plus 0x minus 49. So 1 times negative 49 and a 0. Well, factors of 49, they have to be the same. They have to be the same. So if I put in a negative 49, the only way for me to get 0 is positive 7 and negative 7. Positive 7 and negative 7. So 1x squared, negative 49, positive 7x, negative 7x. I can take out a positive 7, a positive 1x, a positive 1x, and a negative 7. So I factor into x plus 7, x minus 7, and note that this is equal to 0. So I am not done if they're equal to 0. Remember, from there, I have to split into two equations. X plus 7 equals 0. So x is going to equal negative 7. X minus 7 equals 0. X equals positive 7. And my two roots, I have one over here at 7, one over here at negative 7. And there's my parabola. Okay, so let's go ahead and do these two, see if we can get them figured out, and we're going to look at some more trinomials. Again, difference of squares. We only have two terms. That means that middle term is 0. So if I think about this being a 1x squared plus 0x minus 64, my crisscross negative 64 and 0 would give me a positive 8 and a negative 8. Those are the two terms that I need. And go ahead and make my box. 1x squared, negative 64, plus the 8x minus the 8x. Pull my positive 8 out, pull my 1x out. Again, a 1x and a negative 8, and that one's factored. So I have a factor of x plus 8 and x minus 8. Now, this next one may look like a difference of squares because I have just two terms. So maybe I can use this method, but I better take out a GCF first because I see way too many numbers and too many letters. Okay, so let's take out a GCF. So I see the first thing I can do is take out a 2. So 18 divided by 2 is 9. 2 divided by 2 is 1. So there's a negative 1. And then I see I have 2 m's, an n, and 3 n's. So let's take out an n. Okay, let's take out an n. So that's gone, and that's gone. So right now, I'm now looking at 2n, 9m squared minus 1n squared. So now these guys I can do something with. This would be 9m squared plus 0mn minus 1n squared. So here's my x. 9 times negative 1 is negative 9. And 0. Well, obviously that's positive 3 and negative 3. Positive 3 and negative 3. So here I go, throwing it into my crisscross, or my box. So I have a 9m squared and a negative 1n squared. Remember, these are m and n. Negative 3 positive 3. So the first thing I'm going to pull out is a negative 3n. Here I'm going to pull out, oops, take that back, a negative n. Getting ahead of myself, negative 1n. Here I'm pulling out a 3m. This one is a 3m, and this one is a positive 1n. So I'm factoring, so that GCF still has to stay there. Remember, this is my GCF. But what else pulls out of here is 3m minus 1n and 3m plus 1n. Notice how 3 times 3, those are perfect squares. The m and the m are perfect squares, and the 1s are perfect squares, and they're different signs. That's going to really come at us tomorrow pretty strong, so we can kind of practice that difference of squares, maybe with a little bit of a shortcut. All right, let's go ahead and see if we can do these two. So go ahead on the first one, hit pause, make your crisscross and your area model, and see if you can get them solved. All right, let's see how you did. So my crisscross, 1 times negative 42 is negative 42, and I need a negative 1. So when I was working, I know that I found factors of negative 7 and 6. Negative 7 and 6. Again, use your factor generator. Take a look at your numbers. So here is my box. A 1x squared, a minus 42, negative 7x, positive 6x. I can take out a negative 7, an x, and a positive 6. So this is going to factor into an x plus 6 and an x minus 7. Okay, x plus 6 and an x minus 7. Now the next one may look like I'm ready to go directly to my crisscross, but remember, the first thing I have to look for is GCF. And on this top one, I knew I didn't have to do anything because my A was 1. But if I look at the next one, I see there's a 2, a 20, and a 50. So I need to divide this by 2. So I have a 1w squared, a 10w, and a 25. That makes it much easier. So A times C is 25. There's a 10. Well, that one's really easy because I know it has to be a plus 5 and a plus 5. Has to be plus 5 and plus 5. So I have a 1w squared, 5w, 5w, both of these are positive, positive 25. So my 5 is going to come out. My w is coming out, w and a 5. So w plus 5 times w plus 5. And I have a 2. Now I can, since these are the same, I can actually write it w plus 5 squared. Okay, w plus 5 squared. So these are actually the same. All right. One more. Hit pause, take out a GCF, and see if you can factor this guy. All right, let's see how you did. 30, 27, 6. Take out a 3. 10x squared minus 9x plus 2. That's what I'm looking at. Now my A times my C is 20. And I have a negative 9. So how am I going to get a negative 9 if I had to have a positive 20? Well, that's going to be a negative 5 and a negative 4. Negative times negative is a positive. Okay, so now, throwing into my box, here's my 10x squared, my positive 2, negative 5x, negative 4x. What can I take out? Well, I know I'm going to have to take out a negative because if there's a negative in this first box, it has to come out, okay? So I'm going to take out a negative 1. Okay, take out a negative 1. Here, I'm going to take out a 2x. Here, I'm going to take out a 5x. And here, I'm going to take out a negative 2. Okay, a negative 2. Remember, I have to have a positive 2 here, so I have to have a negative and a negative to get rid of that. So if the negative is in the first spot, you're going to have to take out that negative. So 2x minus 1 and 5x minus 2. Let's check ourselves. 10x squared, negative 4x, negative 5x, positive 2. So right there, I see that I'm going to come up with the right numbers. Okay? Okay, and the only thing I'm missing is my 3. That GCF has to drop to get my final answer. All right, so let's keep factoring today. See if you can get it figured out. Get a hold of us if you're struggling, because this is a very important concept.